All right, so we're looking at 1-4. We've actually already talked about the first part. We already talked about how sine and cosecant are reciprocals of each other. Same thing with cosine and secant and tangent and cotangent. Okay, so these are all reciprocals. All right. So what's neat about that is if I have the value for one, I can get the value of the other without having to do too much more math. So if you look at example A, find the tangent of theta given that the cotangent of theta is 4. Well, if tangent and cotangent are reciprocals of each other, and this is 4, that means this must be? Say it with confidence. I know you know. If this one's 4, this one's got to be 1/4 because they're reciprocal functions of each other, right? So that answer is just 1/4. So look at B. Secant and cosine. Well, lucky for us, secant and cosine are reciprocals of each other. So if I'm given this, all I need is the reciprocal of that, so I'd get what's the reciprocal of this thing? Okay, I'll tell you. I'm just going to flip that fraction over, right? What do I do with the negative sign? Does that change? No, reciprocals, it's the same sign. Whatever it was, it stays. So this is now negative root 20 over 2. But you would never leave your answer like that, right? Because even this shouldn't be written like that because, first of all, it's got a square root in the denominator, and square root of 20 can be simplified. But I don't have to worry about that part. I have to worry about this part. So let's simplify the square root of 20. So that's 2 root 5. And then I can reduce those 2's. So I actually just get negative root 5. Okay, so if I am given a value for one of the trig functions and I'm asked to find one of the other trig functions, if it happens to be one of the reciprocals, I can do it very easily. What happens if it's not? Well, that takes a little bit more work, and we're not quite there yet. All right, the next thing we're going to look at, in your coordinate plane, do you remember, I think we mentioned this the other day, labeling the quadrants? This one's 1, right? And then you go 2, 3, and 4. We're going to need to know what the sign of each trig function is in each of the quadrants. Oh boy. Lucky for you, there's a really nice way to remember it all. So, if I'm looking in the first quadrant and I find any angle that lands in the first quadrant, so 10 degrees, 15 degrees, 37 degrees, anything between 0 and 90 would land in the first quadrant, right? Okay, if I found its sine, cosine, tangent, or any of the reciprocal functions, guess what the sign of them would all be? They're all going to be positive, every single one of them. Why? Because if you look at what you're doing to find all of these. You're doing x, y, and r's all kind of divided by each other. Well, if I have a triangle over here, isn't x, y, and r all positive? So it doesn't matter who I'm dividing by what. I'm dealing with positives every which way. So all are positive in the first quadrant. So all of the 6 trig functions are positive in the first quadrant. Now in the second quadrant, that's not true anymore. Over here, let me erase that 2 for a second. If I look at a triangle that's over here, it's going to have some positive y value here. It's going to have some r value, and we already talked about how r is always positive, but x is now negative. So when I start doing my sine, cosine, tangent, and the reciprocal functions, some of these are going to end up being negatives. Well, which of the 6 will be negative? Well, turns out it's going to be sine. And if sine is negative, isn't its reciprocal also negative? Yes, so sine, and then I'll put and cosecant. Down in the third, x and y are going to be negative. R is always positive, but now x and y are both negatives. So as I play around with these, it turns out that here it's going to be tangent that's negative. Oh, wait. Sorry, I think I said that backwards. Here it's going to be sine that's positive and cosine that's positive. Here tangent's positive. And its reciprocal cotangent, also positive. Everybody else is negative. So take a wild guess, who's positive over here? Cosine. And its reciprocal, which is secant. So they're both positive. Everybody else is negative. Okay, so how in the world are we supposed to remember all of this? It's actually really easy if you know this cool little thing. And we start in the first quadrant and we work this way. The little saying that people say is, all students take calc. I know it's not true, but all students take calc. That tells you who's positive in each quadrant. So S obviously stands for sine, T stands for tangent, C stands for cosine. All students take calc. This shows who is positive in each quadrant. First, second, third, fourth. Does that make sense so far? Everybody's all right? Okay, so let's see if we can work ourselves through C, and then I think we can do C and D, and then we'll stop there. All right. So C says, determine the signs of the trig functions of an angle in standard position with the given measure. So what I recommend you do, and I know it's a little tedious, but I'm just going to jot down the 6. Sine, cosine, tangent, cotangent, secant, and cosecant. So all I have to do is indicate what the sine would be for a 54-degree angle. Well, if it's 54 degrees, what quadrant is it in? 1. Who's positive in the first quadrant? All of them. So they're all positives. Well, that was easy. Now we take a gander at 260. Secant, cosecant. Okay, so there's my 6. So we need to take a moment and figure out what quadrant 270 is in. It is in 3, right? Because if you remember, go back here. That's 90, that's 180. This guy's 270, so 260 puts me right over in here somewhere. Okay, so I'm definitely in the 3rd quadrant. So who is positive in the 3rd quadrant? Tangent and cotangent. Which means everybody else must be negative. See how nice? So you just got to figure out what quadrant am I in, who's positive where I am, everybody else is negative. How about a negative 60-degree angle? What quadrant does that land you in? Yes, it'd be the fourth. So if you look back, a negative 60 means that instead of going this way, I go this way. But I'm only going 60 degrees, right? This would be negative 90, so I'm not quite there. I'm somewhere in the fourth quadrant. Okay? Who is positive in the fourth quadrant? Cosine and secant. It's reciprocal. So cosine, secant, and everybody else is negative. All right? That's not so bad. As long as you remember that neat little thing, all students take calc. Or make up your own, whatever you like. But I've actually, it's funny because I think someone randomly, the first year I taught this, someone said something like all students teach calc, and I'm like, oh, it doesn't make sense, but okay, we'll go with it. And then I found out that all students take calc is like a real thing that like is in books. I'm like, wow, that's weird. We got really close to it. All right, anywho, let's try D. D is now asking you to say what quadrant has this condition. So who has a positive tangent but a negative cosecant? So look back at your stuff. Who would have that? Who would have a positive tangent but a negative cosecant? We'll start with the tangent part. Who has a positive tangent? 1 and 3. So it's got to be one of these two, right? And then if it has to have a negative cosecant, well, then it can't be 1 because everybody's positive there. So it's got to be 3. Does that make sense? You try the second one. See if you can come up with the right quadrant that has, that's going to be a positive sine and a positive cosecant. Did you get an answer? Did you get multiple answers? Yeah, it actually works for 1 and 2 because sine and cosecant are reciprocals of each other, right? So if that's positive, the reciprocal is going to be positive anyway. So we have this 2 is definitely a possibility and 1 is still a possibility because everybody's positive there. So that one works in 1 or 2. All right, so I think I'm going to stop this here.